In this video, we'll solve LeetCode 1200 minimum absolute difference. This is a classic sorting plus linear scan problem that shows up often in interviews to test whether you can simplify a brute force idea into a clean, optimal solution. You're given an array of distinct integers. Your task is to find the minimum absolute difference between any two numbers. Return all pairs A, B such that A less than B, B minus A equals that minimum difference. The result must be in ascending order. Example 1. We are given an array containing the values 4, 2, 1, and 3. After sorting the array, the values become 1, 2, 3, and 4. Next, we look at the differences between each pair of adjacent numbers. The difference between 2 and 1 is 1. The difference between 3 and 2 is 1. The difference between 4 and 3 is 1. The minimum difference is 1. Therefore, all valid pairs with the minimum difference are 1 and 2, 2 and 3, and 3 and 4. Example 2. We are given an array containing the values 1, 3, 6, 10, and 15. The array is already sorted. Now we calculate the differences between adjacent numbers. The difference between 3 and 1 is 2, which is the minimum. The difference between 6 and 3 is 3. The difference between 10 and 6 is 4. The difference between 15 and 10 is 5. Only one pair has the minimum difference. The valid pair is 1 and 3. Example 3. We are given an array containing the values 3, 8, -10, 23, 19, -4, -14, and 27. After sorting, the array becomes -14, -10, -4, 3, 8, 19, 23, and 27. The minimum difference is 4. The valid pairs with this minimum difference are -14 and -10, 19 and 23, and 23 and 27. Rate equals x slow. This problem looks like compare every pair, but that would be too slow. The key insight is, after sorting, the minimum absolute difference must occur between adjacent elements. This turns a quadratic problem into a linear one. Let's try brute force approach. Compare every pair, I-J. Track the minimum difference. Collect matching pairs. Time complexity sad face of n squared. This will TLE for large inputs, n up to 100,000. Step 1. Sort the array. Sorting puts close numbers next to each other. Step 2. First pass, find minimum difference. Loop once through adjacent elements to find the minimum difference. Step 3. Second pass, collect all matching pairs. Loop again and collect pairs where the difference equals the minimum. Clean, simple, and interview-friendly. We define a solution that finds all pairs of numbers in an array that have the smallest absolute difference. First, the array is sorted in ascending order so that close values are next to each other. We then initialize a variable to store the minimum difference, starting with a very large value. We also create an empty list to store the result pairs. Next, we loop through the array starting from the second element. For each position, we calculate the difference between the current element and the previous element. If this difference is smaller than the current minimum difference, we update the minimum difference. After finding the minimum difference, we loop through the array again. This time, whenever the difference between two adjacent elements equals the minimum difference, we add that pair to the result list. Finally, we return the list of all pairs that have the minimum absolute difference. Time complexity, sorting. Big O of n log n. Scan. Big O of n. Overall. Big O of n log n. Space complexity. O1. Extra space. Excluding output. Common mistakes and edge cases. Using absolute difference after sorting not needed. Comparing non-adjacent elements. Forgetting that array elements are distinct. Returning pairs out of order. Let's recap. Sorting reveals structure. Minimum absolute difference appears between neighbors. 2 clean passes solve the problem optimally. Interview tip. Whenever a problem asks for minimum difference, try sorting first. It often collapses the problem from big O of n squared to big O of n. That's the mindset interviewers look for.